Hello, my name is Joelle George, and this is my balloon geometry lab, where we're going to be going over the table 9.2, electron domain and molecular geometries of molecules with lone pairs on the central atom. So we'll first start by going over an atom that would have 3 electron domains, represented by our 3 balloons here. The type of molecule you would see with this pattern would be an AB2 molecule. This is the electron domain geometry would be trigonal planar. The number of lone pairs would be 1. And then an example could be sulfur dioxide. So we'll take a look here. So this is kind of another angle of it with our, like we said, our 1, 2, 3 electron domains, and we could possibly, instead of one of these domains, instead of an atom, just have a lone pair of electrons. So that's our first geometry shape. Next we have our atom that has, or our molecule that has 4 electron domains. So we can see, if we turn this around a little bit, our 4 domains here. So there are 2 different options here with this one. So the type of molecule you would see here would be an AB3 molecule or an AB2 molecule. This shape is tetrahedral. You could have either 1 or 2 lone pairs of electrons. And an example would be, for if we had 1 lone pair of electrons, would be ammonia or NH3. Then if we wanted an example of 2 lone pairs, an example could be water or H2O. So that means that for that first example, instead of one of these domains, say this orange balloon, instead of an atom, we would have a lone pair of electrons. Or that second example, we would have 3 atoms and 2 lone pairs, possibly. So that's this one. Oops. All right. Next, we're going to have our balloon structure with 5 electron domains, as we can see here. So I got 2 blues, 2 purples, and a white, which brings us to 5. Like our last example, there are 2 different possibilities here. So first we'll go over the type of molecule that would be AB4. This shape, of course, is trigonal bipyramidal. You can have, in this instance, we would have 1 lone pair of electrons. An example would be sulfur tetrafluoride, which is abbreviated SF4. Alternatively, we could have AB3, in which case that's still trigonal bipyramidal. The number of lone pairs would instead be 2. That would lead us to more of a T shape for our molecular geometry. And an example would be chlorine trifluoride, or ClF3. So that's our first example. The other, it looks like we have 3 possibilities for the 5 electron domains. So in that case, our last example would be AB2. That would have 3 lone pairs. And an example would be iodine monofluoride, or IF2 negative, and the molecular geometry would be linear in that case. So there's actually 3 then for the electron domain of 5. So like we talked about on the other examples, that would be substituting different molecules out for electron or lone pairs. All right, and then we have one more. And this one's a little delicate. Oh, we lost one of the balloons here. Imagine this is also connected to the rest of our structure. It was previously. Okay, so this would be an molecule with electron domain of 6. So we should have 6 balloons all connected here. The first instance, the type of molecule would be AB5. The shape is octahedral. We could have 1 lone pair here, in which case our molecular geometry would be square pyramidal. An example would be bromine pentafluoride, or BRF5. We could also have a molecule that is AB4, octahedral still, of course. In this instance, we would have 2 lone pairs. The molecular geometry would be square planar, and an example would be xenon tetrafluoride. So once again, imagine that this red balloon is underneath there. And we'll kind of zoom around to see the other side here. All right, so that covers the table 9.2. Thank you for listening.